While you may not already be aware of this, M&M's candy colors are a hotly tracked thing in the field of statistics. This is because, unlike some candies, like Sour Patch Kids, where the candy colors are all expected to appear in similar proportions, Mars intends for the M&M candy colors to appear at different rates. But honestly, I'm okay with this because really, who wants more brown M&Ms? Now, if we think about the variable color of a candy, this is a categorical variable. We haven't done much in the way of statistical testing up until now, focusing solely on categorical data. Let's start with remembering how we can organize categorical data. We begin with a table of counts, or a frequency table. Here you can see what one researcher found after collecting a sample of 712 M&Ms. The counts were achieved by looking row by row in a data set and counting the number of times we found a row recording a green M&M or a yellow M&M. We can also calculate the relative frequency of this data. This is just the proportion or percentage of each color represented in the data. We calculate relative frequency by taking the count of how many blue M&Ms there were and dividing by the total number of M&Ms, which was 712. We can make a bar chart to visualize this data. A bar chart is just a visual representation of our table. The height of each bar in this chart corresponds to the counts listed in the table. Visualizations are nice because they allow us to make quick judgments about our data. This bar chart allows you to easily see we have the fewest brown M&Ms, but fairly similar amounts of blue, green, and orange ones. But overall, the rates aren't too different between the colors. Now, here is a pie chart of the same data. As I mentioned before, we aren't big fans of pie charts these days. If you remember from the last chart, we could tell easily that there were slightly fewer brown M&Ms, but in this pie chart, it appears all the colors show up in exactly equal proportions. Pie charts allow us to visualize the relative frequency or percentage of each level of our variable. But once we get beyond about 3 slices, we're limited by our visual ability to pick out the different sizes. So we will just avoid using these types of charts. We can also use a bar chart to show the proportion of the bag that was represented for each color. Putting this next to our previous frequency chart, you can see that our relative frequency or proportion chart and our frequency or count chart look identical to each other than the scale on the y-axis. This is because we are measuring the same thing in both cases. All we changed was the scale. Now look at this chart of M&M colors. For this chart, we would say that it actually looks like there must be about 10 times the amount of green M&Ms than there are brown ones, and twice as many red as brown. But this is actually the same data we just looked at, and we know the proportions for each color aren't that different. Here is my new chart compared to the original chart. In a side-by-side comparison, you can see that they tell very different stories. So what changed? The range of my y-axis. In the chart on the right, I violate a key principle of creating good bar charts, the principle of proportional ink. It basically says that the height of the bars, or the amount of ink they would take up if printed, needs to represent the full amount of the data, so that our eyes can visually tell our brain how these different things compare accurately. To make sure we have proportional ink, we need to have a bar chart that starts at 0. In the chart on the right, I restricted the scale and started at 90 instead of 0. This is what accounts for the exaggerated differences between the colors. Always remember, when we make a bar chart, we want to start it at 0. Otherwise, we run the risk of misleading people with our chart. Let's talk about a few more design principles for making and interpreting a good chart. Remember, the point of a chart is to tell an accurate and easy to understand story about our data. The chart on the left here is bad because the scale for the y-axis is not consistent. Each line coming down from the y-axis should mark an equal amount of increase. Additionally, we are violating proportional ink in a new way. We see a color for excite when the value for that share is actually 0. We shouldn't see any color for a value of 0. On the right, this is both a pie chart and 3D, which gives us 2 strikes for making it a misleading chart. This chart makes it nearly impossible to compare the schools because of the different sizes of the rings. This leads to things that are identical, like the TCU and OSU percentage, to look like they are actually different amounts. There are many different ways we can represent frequencies and relative frequencies in charts, and some are better than others. Remember that just because you can make a chart doesn't mean you should. If a reader can't clearly understand what you're telling them, then no matter how pretty the chart is, it's a worthless chart. The key principle to remember is that the amount of colored space you see should directly correspond to the actual proportion for a variable. And readers should quickly be able to see differences between categories without these being inaccurately exaggerated.